China just released data that NASA has been hiding for months, and what it reveals about Oumuamua will change everything you thought you knew about this mysterious object. While NASA keeps telling us Oumuamua is just an unusual interstellar comet passing through, China's National Space Administration just dropped a bombshell. Detailed tracking data showing Oumuamua doing things that comets simply cannot do. Propulsion burns, controlled navigation, systematic course corrections, and electromagnetic transmissions with structure far too complex to be natural. This isn't theory or speculation. This is hard evidence from advanced space tracking networks. Evidence that directly contradicts everything NASA has been saying publicly about Oumuamua. The Chinese data shows Oumuamua slowing down and speeding up on command. It shows lateral movements that require engines, not just gravitational drift. It shows the object making 17 separate course corrections over 2 weeks, each one precisely timed and executed. And most shocking of all, it shows Oumuamua deliberately altering its trajectory to bring itself closer to Earth than its original path. NASA has known about these capabilities for months. They've tracked the same maneuvers. Their telescopes have captured the same evidence. But instead of sharing this information with the public, they've stayed silent, publishing reassuring statements about a natural visitor while their classified data tells a very different story. Before we break down the shocking capabilities China just exposed and why NASA has been hiding them, hit that like button and subscribe, because what you're about to learn about Oumuamua will completely shatter the official narrative. China's release of this data wasn't just scientific transparency. It was a direct challenge to NASA's cover-up. And the evidence they provided proves that Oumuamua is far more than just a space rock. It's something with technology, intelligence, and a specific destination in mind: Earth. China's space tracking network has been monitoring Oumuamua just as closely as NASA, maybe even more closely. And what their telescopes captured over the past weeks reveals capabilities that transform Oumuamua from an astronomical curiosity into something far more significant. The Chinese observations show Oumuamua performing velocity changes that natural objects cannot execute. In one documented sequence, Oumuamua decelerated by 5,000 miles per hour over a 12-hour period. 3 days later, it accelerated back to its original velocity. That's not gravitational influence or solar wind effects. That's powered flight. An orbital mechanics specialist who reviewed the Chinese data explained the significance. When you see velocity changes like this with these specific acceleration profiles, you're looking at thrust engines firing controlled propulsion. Natural space objects don't slow down and speed up on command. This is technology, not geology. The Chinese tracking stations also captured Oumuamua making lateral course corrections, sideways movements that adjust its trajectory without changing overall velocity. These maneuvers require thrust vectoring, the ability to direct engine power in specific directions. It's exactly what spacecraft do when making precise navigational adjustments. Over a 2-week observation period, China documented Oumuamua making 17 distinct course corrections, each one precisely timed and executed to alter the object's path through space. The pattern suggests active navigation toward a specific destination rather than passive drift through the solar system. But the propulsion evidence is just the beginning. China's radio telescope arrays captured detailed recordings of electromagnetic transmissions from Oumuamua that reveal complexity far beyond anything NASA has publicly acknowledged. The signals aren't random noise or simple pulses. They're structured communications using multiple frequency bands, showing characteristics of advanced data transmission, modulation patterns, error correction codes, and what appears to be packet-based information transfer similar to how our own digital communications work. One particularly striking finding: the Chinese data shows Oumuamua's transmissions adapting based on environmental conditions. When solar radiation increases, the broadcast frequencies shift to avoid interference. When Oumuamua moves behind the sun from Earth's perspective, the transmission power increases to maintain signal strength. That's not automated response. That's intelligent adaptation. Beyond tracking and signals data, China released high-resolution imagery of Oumuamua that reveals surface features unlike anything seen on natural space objects. The Chinese space-based telescopes captured Oumuamua from multiple angles as it rotated, creating detailed, three-dimensional maps of its structure. What those maps show has sparked intense debate in the astronomical community. Oumuamua's surface displays geometric patterns, areas with regular spacing, precise angles, and symmetrical arrangements that look extremely unlikely to form through natural processes. One region shows what appears to be a grid of rectangular structures, each approximately 50 meters across, arranged in perfect rows. A planetary geologist who analyzed the imagery described the anomaly. Natural geological processes create irregular features, random crater impacts, uneven weathering, chaotic fracturing. What we're seeing on Oumuamua are ordered patterns, regularity, precision. Those characteristics suggest artificial construction rather than natural formation. Another striking feature captured in the Chinese images. Oumuamua appears to have distinct sections with different surface properties. Some areas are highly reflective, almost mirror-like. Other regions are matte and dark. The boundaries between these sections are sharp and linear, not the gradual transitions you'd expect from natural material variations. Most intriguing are the thermal observations. Chinese infrared telescopes detected heat sources on Oumuamua's surface that don't correlate with solar heating patterns. Some areas are warmer than they should be based on sun exposure, suggesting internal heat generation. That implies active power systems operating inside the object. The thermal signatures also show regular cycling, periods of increased heat followed by cooling, then heating again in predictable patterns. One area pulses with a heat signature that cycles every 4.7 hours with clock-like precision. Natural thermal processes don't maintain that kind of regularity. China's spectroscopic analysis adds another layer of mystery. The composition readings show materials that are extremely rare in natural space objects. Specific alloy combinations that require precise temperature control and manufacturing processes to create elements in concentrations that don't match any known asteroid or comet profiles. The data reveals significant quantities of titanium, vanadium, and rare earth elements in configurations that suggest they were deliberately combined rather than naturally formed. These are the kinds of material signatures you'd expect from advanced manufacturing, not from a primordial chunk of ice and rock. Perhaps the most damning evidence in China's release concerns Oumuamua's trajectory, the path it's taking through our solar system. And this is where things get truly unsettling. NASA's official trajectory data shows Oumuamua following a hyperbolic orbit, coming in from interstellar space, swinging past the sun, and heading back out. A simple one-time visit from a traveler passing through. But China's tracking data tells a completely different story. The Chinese observations show Oumuamua making deliberate course adjustments that have systematically altered its path. These aren't minor gravitational perturbations. These are substantial trajectory modifications that have changed where Oumuamua is heading. An aerospace analyst examining the Chinese trajectory calculations explained the implications. Based on Oumuamua's original approach vector, it should have passed through the inner solar system and departed. But the course corrections documented in China's data have bent that trajectory significantly. Oumuamua is no longer on an escape path. It's maneuvering into a trajectory that keeps it in the inner solar system. The data shows Oumuamua making specific adjustments at key points. Burning engines when gravitational assist from planets would maximize the efficiency of each maneuver. This is exactly what spacecraft mission planners do when designing fuel-efficient trajectories. Sophisticated orbital mechanics being executed in real time. Most concerning, the modified trajectory brings Oumuamua much closer to Earth than its original path would have. China's calculations project Oumuamua passing within 3 million miles of our planet, less than 13 times the distance to the Moon. From an astronomical perspective, that's uncomfortably close. But here's what really has analysts worried. Oumuamua's current trajectory has it approaching Earth from a specific angle that would make it extremely difficult to observe from ground-based telescopes during the closest approach. The geometry positions Oumuamua in a location where it would be visible primarily from space-based assets and a narrow band of Earth's surface. A military space analyst described this positioning as suspicious. If you wanted to approach Earth while minimizing observation opportunities, while reducing the number of tracking stations that could monitor you, you'd choose almost exactly this trajectory. It's either an incredible coincidence or it's deliberate planning by whatever controls Oumuamua. The Chinese data also shows Oumuamua performing what's called orbital reconnaissance, flying past targets at distances and angles optimal for detailed observation. Oumuamua made these kinds of passes near Mars, gathering data about the planet's composition, atmosphere, and surface features. The same pattern appears to be setting up for Earth. China's trajectory projections show multiple possible futures for Oumuamua after its Earth approach. Some paths show it continuing deeper into the solar system. Others show it using Earth's gravity to modify course towards specific destinations, the asteroid belt, Jupiter's moons, or even back toward Mars. But several of China's projections show something that NASA has never publicly discussed: the possibility of Oumuamua inserting itself into orbit around Earth. The calculations show it's entirely possible given Oumuamua's demonstrated propulsion capabilities and current trajectory. Oumuamua could, if it chose to, park itself in Earth orbit and stay there indefinitely. China's radio telescope data reveals something NASA has barely acknowledged. Oumuamua isn't just broadcasting randomly into space. It's attempting to communicate. And the sophistication of those attempts suggests intelligence that understands communication theory and information encoding. The Chinese data shows Oumuamua's transmissions evolving over time. Early broadcasts were simple mathematical sequences, prime numbers, geometric ratios, basic constants that any technological civilization would recognize. But as weeks passed, the transmissions became more complex. Recent signals captured by China's arrays include what appears to be encoded imagery, data patterns that when processed through various decoding algorithms might represent visual information. Some researchers believe these could be star charts showing Oumuamua's point of origin. Others think they might be diagrams explaining Oumuamua's purpose or capabilities. A communications engineer analyzing the Chinese data described the sophistication. These transmissions use layered encoding, multiple types of information packed into the same signal. There are clearly identifiable header sequences that mark the beginning of data packets. There are error correction codes that would allow reconstruction of information even if parts of the signal were lost. This is professional-grade communication engineering. What makes this particularly intriguing is that Oumuamua's signals show adaptation. When China's radio telescopes transmitted experimental responses toward Oumuamua, the object's subsequent broadcasts incorporated elements from those transmissions. Oumuamua is listening, processing what it receives, and adjusting its messages accordingly. This represents interactive communication, not just blind broadcasting. Oumuamua appears to be trying to establish a dialogue, testing different approaches, modifying its strategy based on whether it receives responses. That's behavior consistent with intelligence actively seeking contact. The Chinese data also reveals that Oumuamua's transmissions aren't omnidirectional. They're beamed, focused broadcasts aimed at specific targets. Some transmissions are directed toward Earth. Others aimed toward locations in deep space, possibly communicating with origin points or other objects we haven't detected yet. Most intriguingly, China captured Oumuamua sending focused transmissions toward specific Earth locations, not just toward the planet generally, but toward particular coordinates on the surface. These targeted beams were aimed at major population centers, significant geographical features, and interestingly, toward the locations of large radio telescope arrays. It's as if Oumuamua knows where our communication facilities are located and is specifically trying to get their attention, either through remarkable detection of our electromagnetic emissions or through prior mapping of Earth's infrastructure. Oumuamua has identified where humans might be listening and is directing messages to those locations. China's release of this data puts NASA in an impossible position, and their continued silence speaks volumes about what they know but aren't saying. When another major space agency publicly contradicts your official narrative with hard evidence, standard protocol is to respond. You either refute the claims with your own data, acknowledge the discrepancies and explain them, or engage in diplomatic channels to reconcile the differences. NASA has done none of these things. No press conference addressing China's findings. No technical paper challenging their methodology. No statement explaining why Chinese observations would differ so dramatically from American data. Just silence. A former NASA public affairs specialist explained what this silence likely means. NASA doesn't deny China's findings because they can't. Their own classified tracking data probably shows the same things China just released. The silence isn't confusion. It's calculated strategy to avoid confirming information they're not ready to share publicly. But the silence creates its own problems. Every day NASA says nothing, more people see China's evidence and start questioning why America's space agency won't respond. The void of information gets filled with speculation, conspiracy theories, and erosion of public trust in NASA's credibility. Some analysts believe NASA's silence is coordinated with other Western space agencies to present a unified front of no comment rather than validate China's claims. But that strategy is failing as more nations review China's data and find it compelling. Russia quickly released a statement agreeing with China's assessment. India's space program published observations that align with the Chinese findings. Even some European scientists have broken ranks to say China's data matches what they privately observed but weren't authorized to discuss publicly. NASA might also be silent, because acknowledging China's evidence would require explaining why they've been downplaying these capabilities for months. Admitting that Oumuamua has propulsion, maneuvering ability, and communication systems would validate everyone who questioned NASA's just a common narrative. It would make NASA look either incompetent for not detecting these features or deceptive for hiding them. There's also the national security dimension. If Oumuamua represents advanced technology that could potentially be studied, understood, or even retrieved, that technology has enormous strategic value. The nation that makes first contact, establishes communication, or gains access to Oumuamua's systems would possess a massive technological advantage. From this perspective, NASA's silence might be part of strategy to avoid revealing the full extent of American intelligence about Oumuamua. By saying nothing, they don't confirm what they know, don't acknowledge capabilities that China revealed, and maintain flexibility for classified response options. But perhaps the most concerning explanation for NASA's silence: they're just as confused as everyone else. Maybe NASA doesn't have good answers for what China revealed. Maybe their own analysis is incomplete or contradictory. Maybe they're staying quiet because they genuinely don't know what Oumuamua is or what it's doing, and admitting that uncertainty would be worse than saying nothing. China's release of Oumuamua data has triggered responses from nations and space agencies worldwide. And the picture emerging suggests a planet deeply divided about how to handle this situation. Multiple countries have upgraded their space surveillance capabilities specifically to track Oumuamua independently. India announced accelerated deployment of new tracking stations. Australia is coordinating with Asian partners to create a Southern Hemisphere observation network. Even smaller nations are dedicating resources to Oumuamua monitoring, unwilling to rely solely on NASA or Chinese data. The European Space Agency held emergency consultations with member nations about coordinating a unified European response. The discussions reportedly focused on whether to align with NASA's cautious approach or acknowledge the validity of China's more alarming findings. The fact that they're even debating this shows how uncertain the situation has become. International scientific organizations are also split. Some astronomy groups have called for complete transparency about all Oumuamua observations, arguing the public deserves full disclosure about what might be first contact with alien intelligence. Others support NASA's cautious approach, warning that premature or incomplete information could cause unnecessary panic.